Okay, so let's start with the last part of this project. Um, I think I will not publish more update on the project itself. Uh, I think I will just publish the whole project in on Axer. So um, right now we will just see what I have implemented in the last days and during my free time. As I said before, I have a lot of things to do. This is not my job, so I do this on my free time, and you you don't usually have the time to improve the stuff and do all the stuff as you want. But I reached a good stage, and I think the contest is near the end, so I think I will need to yeah, I need to write down all the things to make it works and my opinion on the board and so on. So actually I have implemented Alexa integration, and to make it possible this integration I had to use another board since the Sony Spresense board doesn't work with Wi-Fi, and to play with Wi-Fi I had to use another device, that is the ESP8266, and it's a popular device, very cheap, and um, there is sorry for the light, there is a library that's called Foxmo that is able to um, emulate an IoT device that Alexa recognize. So what we do with this ESP8266 is to load a project in order to make it recognizable by Arduino, by Alexa. So you will see a lot of tutorial on this subject. On the ESP8266, you will it is available on many board, on many type of board. Um, the simplest, the simple one is it's around $4, €5, something like that. No more. I used a Node MCU board that it's like that. This is a Node MCU board like is shipped with another firmware with usually with a Node. There's not a Node.js. It's a Lua like um, programmable operating system, Flash microcontroller system. So if you buy something like that, the first step to do is to flash all the Arduino stuff. In order to do this, let's see this tutorial. If it's okay, there's a YouTube video. You will find many documentation all around the web. I had some problem because the last I had Mac OS X. It's it's Sierra, and this Sierra with the serial USB to serial controller is not really compatible. So I had some crashes using this board and trying to program it, and that's why I don't want to show you a lot of stuff on this, because I don't want to crash during the streaming. but what can I say about it? It's just you have to install the driver. On Linux, I don't know, on Windows there are drivers, but you will find the drivers. It's CH340 driver, and then once you have done that, you will have to do something like connecting to make the Arduino IDE recognize this board. In order to do this, you have to add some. Let's try to see it on preferences. Yeah, on the additional board, you have to add some these packages. This one. Sorry. What I'm doing cancel. So as you can see, there is this line. It's for the Arduino ESP, so it's compatible with it makes Arduino IDE compatible with this board, and then so you have to add the board down here on board manager and add the board and so on. At the end you will have this section, this new section. As you can see, these are all the board you will find you can buy with ESP board, and you can then also open some example and test the board. What it will do is to flash a new firmware for the board, and it making it compatible with Arduino IDE. So you write like another Arduino board, but it's like an Arduino board with some not really exactly like an Arduino, but it's a Wi-Fi controlled Arduino. So you can also write stuff for Wi-Fi, and that's very powerful with a very cheap price. So once you flash the board, I suggest to use the example and try to just, for example, blink a LED. It's the yellow word for all these kind of board. Where is the ISP? I think it was there. It's no more there. Okay, I was sure to seen it before, but I'm very tired, and so I'm not really sure. I don't remember, but anyway, once you done that, you can, let's see, board. Okay, this is available. Examples, reach any board. Spresense, these are the example for our board, and then I'm sure I was sure there was something here. Okay, anyway, okay. Anyway, once you try the board, make it try to just blink a LED. There is a LED built in inside, so you can switch on, switch off the LED just to see if something is if it's all correct. On this non MCU there is a LED built in, so, and so you see something like that, a blink that. And then what I have done is to load the library that emulates another device, and the code is something like that. Let's just see some piece of code. So there is you have to place Wi-Fi password, SSID, and then all this stuff. What it does is to just set up the Wi-Fi, and once the setup is correct, so at the setup it's called Wi-Fi setup. Wi-Fi setup sets the Wi-Fi station mode, and so in order to connect, because this board can act also like an access point, and both, so you have 3 mode. And then you try to stay in a infinite loop until the Wi-Fi connection is established, and then you set something on the serial line. Once you've done the Wi-Fi setup, it creates 2 devices, but we just need to add one, and I added a device called Jukebox. And then there was here what I've done here. So once you've done that, there is a loop with a FAXMO handle that I think call a sort of loop inside this handle, and once the state of the device change, because you said something like Alexa switch on Jukebox or Alexa switch off Jukebox, it changed the device state. So here you control these. To make the board, the ESP8266 board, talk with my Spresense, I had 2 choices. The first one was to connect the both board are there is a receiver and transmitter pin. So these 2 pins, and also on the Arduino side on the Spresense, it's a serial line. So you can connect. You have to connect the RX with the TX and TX with the RX on the board. So you have to flip, and once you've done that, you can talk with these 2 boards by the serial line, so they can speak sending serial. So for example, you can have this code that when you switch the state on, so you said, for example, so what it should happen. You said something to Alexa. Alexa recognize this device. You have set up the ESP8266, and this device translate the message on a state on, for example. If you say Alexa switch on, when you receive this, you send a message with the serial line to the other board, to the Spresense. And if you switch off the device, you do the same, you send another message. I didn't want to use the serial line because I think it's complicated to debug, and I just have to have a switch. So my ESP8266 is like a switch. I want to say switch on, switch off, and stop, and I don't want anything else. So I decided to do something different, and I connected 1 pin of this board. I connected this pin, I think, this pin to one of the pin of the Spresense. What is good with the Spresense is it's possible. This device works with 3.3 I/O level, and the Spresense, there's a switch. This is a very nice feature. There's a switch to change the I/O level from 5 volt to 3.3, and that is very cool. It's a very cool feature. So I don't have to put between these two boards a level shifter in order to translate the level of these two boards, but it's just integrated on the board. And so every time I add to every time I see something, say something. So here there was a print. Sorry, I did set up the pin, and then here I write the pin. So the two board is connected. There's the ESP8266 send a high mass level when it's something when it's on, and it's no, sorry, it's the opposite, because the board works in the opposite way of the Arduino. So high is when you switch off, and low is when you switch on something. So if I send a low pin, it's like, so if I receive a message of switch on jukebox, I send a low to the Spresense board, and if I receive a switch off, I send a low. So and a high is so in some way, in one way it's an high, in another way it's a low, and that's it. So it's the ESP8266 is just a switch. And if I hope you hear everything. Let's try. But I opened the Alexa app, and I already configured the device. So I'm sorry, I'm Italian, so this is a demo with Italian voice. So let's try. Alexa, accendi.
Non trovo nessuna skill video.
Ok. Alexa, accendi jukebox. I think you are listening. Okay. And if I said, Alexa, spegni jukebox, and it's switch off. So to do this, let's see the code. To do this one, so the code is growing a lot. I publish all this stuff online, so don't worry if you don't see it. If you don't see everything right now, if I will miss to publish the code, please ask me in the comments, and I will send you the link immediately, and I update the description. But I will do the next week when all the projects will be over. So let's see what I've done. If you remember the previous one, there was a check buttons. The check buttons now is a little bit bigger, and there is always this check for the pressed button, but there is another one thing. This other one thing is there is a from Alexa, that is the pin. So the pin number 4 of my Spresense board control the message, the digital level coming from the ESP board and from the Alexa. So if from Alexa the pin is low, there is a Alexa said switch on, receive the switch on, and so if I'm set up, I do play the audio, the mp3, and there is a new function that we will see very soon. If it's not Okay, and is Alexa controlled. If it is not, it's playing. So if it receives a low Nike, it means it's Alexa set to switch off, receive to switch off. And so if there is Alexa controlled, so if it's this makes sense, because if you activate Alexa for this device, it will start to work with Alexa. If it's not, this pin will always be high. It means if it's not usually if it's not connected to Alexa ESP, we will send a low message, sorry, a Nike pin, and so it will continue to stop if it's play. So if I push the button, the physical button, and I press to play, this code can stop it. So that's why I inserted this boolean, but I think the best way is to add a micro switch to set like control by Alexa or control by physical controller. In my original idea, there is a dock, so the ESP section should work with like a dock, and so if you are in the city and you are going to work, for example, you bring with you just the mp3 player and listen to it and so on. When you come back to home, you have to plug it on the dock, and then it's Alexa enabled. So, and that's it. But the other interesting stuff I did was to clean a little bit the code and move something. So for example, the setup code right now is very small, but there is a playNext file that is a bigger function. And what it does is to initialize the player, and it should be initialized every time. I don't know why, but if not, it will say that will report an error every time and it will stop. And so when you switch the file, I add to init player, and then there is always the usual volume control, set volume, and then there is this one that is load SD file. Let's check it, this function. So what I've done here, in this SD card currently there are 3 files. There are 3 song files. So you can see there is Alexa forever because it's activated. So let's tap it, and in this code, it helps you to load the next file. So I have a variable, a global variable, that is file edx, that is like load the first file load on the file system on the SD card. And it's like that. It's like, okay, open the root of the SD card and check, list all the file on the slash directory, and it just run all the file on the root. If you have something on the other directory, it will not work, this code, but it's okay for now. It's just a prototype, it's not a commercial one. So you will have something like that. For example, there's a hidden file. Other file is a directory. What you want is to load only mp3 file to play, and that's why I inserted a sort of filter. Let's check if the name of the file is point, start with the points and ends with the mp3. If it's not ended with this code, it go on, it doesn't check it. And then here, this code control if you are, so it at the beginning current will be 0. So you have a list of files like that, like this one, and at the beginning file edx will be 0, current is 0. So at the beginning we'll set current if it's a valid file, and current is equals file edx, so close the file. If it's not closed, and open a new one. This file is the one we will play. Then it said close the entry, this file. So write something on the serial line, and it said file found. So there is also a variable to keep track, like if we don't have any good file, we will have to go on, or we will try to read at least the first valid file. We hope to. So it's a kind of a loop searching for files, available files. If it's all okay, so the file, we found the file, and at the beginning we will find the song1 file, for example, we will move the file edx to the next one, and we stay there. So we can go back to next. So play next file. We were here. So we have the new file to play. We change the mode. We buffer a little bit of the first file, and we start to play. So this function is called into place. The first one we call it when we are three place. The first is the button. When you press the button, you roll the first track, and when you stop and you start the next track. Of course, if we put another button, we can do stop and next. That is different. If it's on Alexa, it's try to load the next file. And I like the idea that if you every time you load a new track, so forever. Of course, if you switch off the board, it will always start from the 0. So we should also save the settings of the player, and so this file edx, we should save it on a file on the SD card, and so every time you start the board you have to read this, and so you know where you were the last time. And we should do it, but we don't have too much time. So the next stuff we did, sorry I hover on the device, the next place where we do this, Alexa of course, and then in the loop, the main loop, we check if we are stopping, we stop, check the button. If it's not, we try to buffer a little bit more of the file. So this code check if we have reached the end of the mp3, and if we have reached the end, we stop the player, we close the file, we go to the next file, so we load the next file, and after the first one file, so this this file index will be 1. Okay, so the beginning was 0, then we check for the, so at the beginning we load this file, then we will check again the list, but we have the first time we will see this is current will be 0 and this will be 1. So the first check will go on. The second one, the file is not valid because we have a point, for example, and then so it's go on, and this filter is very poor. We have to improve it a lot, or we have also to, maybe there is a mp3 file that is with a good file name but a wrong content, so we have to manage this kind of errors in some way. Like for example, go on, write something and go on, but it's just a simple filter. And then so this file will be ignored, and then we will arrive finally to this file, and at this time this will be current will be 2, because we increment this current only when we find valid file name. Okay, so it will find song2 and it load this song2, and that will work also for the other files. So, and let's play for the last time this project. Okay, I don't know if are you hearing it, but if I press stop again and I press play again, okay, this will, so start, stop, start with a new one. Let's try with this one that is shorter, and let it play. So in this way we will see if we will change to the next track, and you will see it will change. Okay, let's, maybe it was better with the, okay, I'm sorry, I pressed the initialize library because it's better with this. As you can see, there is a song 1, play this file, press the first button. So this is just a recap. I hope you enjoyed this video. If you have any question, any comments, okay. If you see right here, you load the list again, and you find the song 2, and now it played the song 2. So thanks for watching all this video. I hope you enjoyed it. If you have any comments, an idea, something you want to ask me about this board, let me know. I just try to show you something about this board connected. Oh, come on. Yeah. Okay. This is the ESP one. And if I said, let's try. No, if not. So, goodbye, good night, and see you next time. Bye bye. With the next project.